Our next topic is agents and environments. What is an agent? An agent is anything that can be viewed as perceiving its environment through senses and acting upon that environment through actuators. So simply we can say that agent is a decision maker. And here we can see the sensors that perceive the environment. So that means it will collect information from the environment. And the agent will decide which action we have to perform, and accordingly these actions are done through actuators. So for example, we can consider human is an agent. Then eyes, ears will be the sensors, and hands, legs will be the actuators. For example, if we are considering robot as an agent, then camera, IR sensors will be the sensors that collect information from the environment, and the actions are done using motors. For a self-driving car, there will be camera, GPS as sensors, and steering and brakes will be the actuators. If you are considering a chatbot, and text input will be the sensors that collect information, and text output will be the actuator. So the percept means what the agent sense at one moment. And here we can see an agent's percept sequence is the complete history of everything the agent has ever perceived. So that means percept sequence means memory of all perceptions till now. In general, an agent's choice of action at any given instant can depend on the entire percept sequence observed to date, but not on anything it hasn't perceived. So that means an agent cannot guess. It only uses what it has sensed. Agents act rationally based only on percepts, not hidden information. And one more thing, what is an environment? Environment is anything outside the agent that it interacts with. So for example, we can say that for a chess program, chessboard is the environment. For a vacuum cleaner, room will be the environment. For a student classroom, so we can say that agent and environment are always considered together. So this is the structure of an agent. Here in this figure, we can see that the sensors that perceive the environment, that means it collect information from the environment using the sensors. And there is a square box we can see, that is the agent program. Accordingly, it will do the decision making process. And then after completing the decision making process, and these actions are done using actuators. And here, this is the explanation for that. Here you can see agent means architecture plus agent program. So sensors that is used to perceive information from the environment, and some examples are given here. And then actuators used to act upon the environment, and the examples are also listed below. Then what is an agent program? So agent program means a set of rules or algorithms that map percepts to actions. So we can say that that implements decision making logic. So in the structure we have seen a square box. So actually that is the agent program. An agent program means there will be a set of rules. And according to that rules, some conditions and rules will be there. And so according to that, the agent will decide what action we have to perform. So agent architecture is the hardware or software platform on which the agent runs. For example, we can say that robot hardware, computer system, virtual environment, etc. Next is agent function. So how does Google Maps decide which route to show you? So behind this decision is something called an agent function. So agent's behavior is described by the agent function that maps any given percept sequence to an action. So we can say that agent function means what the agent should do. That is, according to theory, we can say that what the agent should do is the agent function. And agent program means how it is actually coded. That is a practical way. And one agent function can be implemented by many different programs. So agent function for an artificial agent will be implemented by an agent program. So we can simply say that agent function is an abstract mathematical description and the agent program is a concrete implementation running within some physical system. So these are the functions of an intelligent agent. First one is perception. We already discussed, collect information from the environment using the sensors, and after perceiving the information, it will convert the raw data into a meaningful perception. For example, self-driving car detect road signs using cameras. That is an example. And the agent program has to work on it. So whatever data collected from the environment, that should be converted into a meaningful format. Next function is decision making or reasoning. That means evaluate the percepts to decide the best action. So for that it uses rules, search algorithms, knowledge bases and machine learning models. Using this, it will find the perfect or best action. Next is action. So after finalizing the action, they execute actions through actuators that affect the environment to achieve the goals. For example, we can say that robot picks an object. For a self-driving car, applying brake or turn the car to left or right. So all these are actions. Then learning. Another function is learning that improves the performance based on experience and also adapt to changes in the environment. For example, recommendation systems learning user preferences. Next function is goal achievement. So that means whatever action the agent is taking, that should reach to the goal. So works towards achieving specific goal efficiently. So uses performance measure to evaluate the success. We will see what is performance measure in the next coming slides. So we will see the example, vacuum cleaner world. The vacuum agent perceives which square it is in and whether there is dirt in the square, and it can choose to move left, move right, suck up the dirt or do nothing. You can see in the figure, you can see there are two squares A and B and one vacuum agent is there, and what it will do is it will first check where it is and there it is clean or not. So if A is clean, if it is placed for initially it is placed in square A and it will check whether it is clean or not. If it is clean, then it will move to the next square B. And if it is not clean, then it will first clean A, then move to the next square B. So one very simple agent function is the following. If the current square is dirt, then suck, otherwise move to the other square. That is the vacuum cleaner word example. So here we can see what are the percept sequence. So first percept is A is clean. So the action will be right. So that means if A is clean, then it has to move to the next square B. Then another percept A is dirt. Okay, if A is dirt, then what will be the action? Then it will suck the dirt. So the action will be suck. Then B is clean. So B clean, then it has to move to the left. That means it has to move to A. Then B is dirt. Again suck. Then you can see the percept sequence. Initially A is clean and then again A is clean. Then also move right. A is clean, A is dirt, then the action will be suck. So you can see the percept sequence on the left side and the corresponding actions on the right side of this table. Next is rational agent. So what is a rational agent? A rational agent is one that does the right thing. Conceptually speaking, every entry in the table for the agent function is filled out correctly. For each possible percept sequence, a rational agent should select an action that is expected to maximize its performance measure given the evidence provided by the percept sequence and whatever built-in knowledge the agent has. So that means when we are considering an agent, Agent has some prior knowledge about the environment that we can consider it as the built-in knowledge that is available in the knowledge base. And the sensor will collect information from the environment that will be the percept sequence. And the agent function that will find the better action based on this. And these actions that is expected to maximize its performance measure. So a performance measure is how we decide whether the agent is successful. For example, we can say that for a vacuum cleaner, cleanliness, low power usage will be the performance measure. For an intelligent agent, an agent that perceives and acts. That means collect information and accordingly they will act. A rational agent is an intelligent agent that acts optimally according to a defined performance measure. So we can say that all rational agents are intelligent agents, but not all intelligent agents are rational. Next, we will discuss about nature of the environment. How does an AI system decide what is the right action at a given moment? It depends on the nature of the environment and four important factors. So we will see what are the four factors. First one is performance measure that defines the criterion of success. Second one, agent's prior knowledge of the environment. And third one, actions that the agent can perform. And the fourth one, agent percept sequence to date. So for example, if you are considering a taxi driver or self-driving car, then we can say the performance measure we can consider safety, speed, comfort, profit will be the performance measure. Then agent's prior knowledge that we can consider it as traffic rules, city maps. Then the action that the agent can perform that we can consider it as accelerate, brake, turn. Then agent's percept sequence to date. That means traffic signal changed from green to yellow, yellow to red. So we will see peace. What is peace? Performance, environment, actuators and sensors. So simply we can say that peace is used to describe the task environment of an agent. So when we are designing a agent or when we are designing an agent system, we have to consider these four factors: performance, environment, actuators and sensors. So here we will see a table. The table fully defines the task environment for a taxi agent. Here we can see taxi driver performance measure is safe, fast, legal, comfortable trip, maximize profit, etc. Then environment, roads, other traffic, pedestrians, customers. Then actuators means steering, accelerate, brake. Then sensors, camera, sonar, speedometer, GPS, etc. Then other examples we can see medical diagnosis system where performance measure is healthy patient and reduced cost. Environment is patient, hospital staff, and actuators means display of question, test, diagnosis, treatments, referrals, and sensors mean keyboard entry of symptoms, findings, patient's answers will be the some we can consider it as sensors. So other examples are given here. You can see satellite image analysis system. There the performance measure we can consider it as correct image categorization. That will be the performance measure. And the environment is downlink from orbiting satellite. And actuators display of scene categorization and sensors color pixel arrays. Next is part picking robot. So here the performance is percentage of parts in correct bins. So the environment is conveyor belt with parts bins. Then actuators, joint arms and bat, and sensors, camera, joint angle sensors. Then refinery controller. There the performance measure is purity, yield safety, yield safety. Then environment is refinery operators. Then Actuators are valves, pumps, heaters, and display, and the sensors, temperature, pressure, and chemical sensors. Next example is interactive English tutor. There the performance measure is student score on test, and the environment is set of students testing agency, and actuators is display of exercises, suggestions, corrections, then the sensors, keyboard entry. Then next we can see agent programs. So agent program, that is a software that runs inside an agent. It takes percepts as input, the percepts as inputs, and produces actions as outputs. So here we can see a function, that is a table driven agent decide what to do by looking at a table that maps every possible percept sequence into an action. So here we are considering a table driven agent as the function and percept as the input, and the output is an action. So each time the agent receives a new percept, this function is called and output is one action. So here the next line you can see persistent means the data is remembered across function calls. So percept store all the percepts the agent has received so far. Initially the table is empty because the agent has not sensed anything yet. And here you can see that each entry will be added to the or appended to the table, and that is indexed by percept sequences. So agent remembers everything it has pursued so far. This forms the percept sequence. And agent searches the table, finds the action corresponding to the current percept sequence. So no thinking, only just looking in the table. That is only lookup. So then agent executes the selected action. The persistent percepts store the complete percept history, and the table maps each percept sequence to a predefined action. Next we will see type of agent programs. In artificial intelligence, agents are classified based on how they make decisions and act. So there are different types of agent programs. The first one is simple reflex agent. Second one, model based reflex agents. And the third one, goal based agents. Fourth one, utilities based agents. Then learning agent. And the last one is hybrid agent. We will discuss one by one in detail. First, we will discuss simple reflex agents. So these agents select actions on the basis of the current percept, ignoring the rest of the percept history. So that means it will not consider the history or percept sequence. It will only consider the current percept, and accordingly it will select the action. For example, a vacuum agent is a simple reflex agent because its decision is based only on the current location and on whether that location contains dirt. It is not checking the percept sequence. It is the vacuum cleaner world that only considers the current percept. Whether there is a dirt is there. If there is dirt is there, it will suck. Otherwise, it will check the location, and according to the location it will decide whether it has to move left or right. So here we can see the program reflex vacuum agent. Their inputs are location and status, and it returns an action. So it will first check the status. If it is status is dirt, then return suck. Then the status is not dirt, then it will check the location. If location is A, then the action will be right. And if location is not A, it will check whether it is B. If it is B, then return left. Simple reflex behavior occur even in more complex environments. So we can consider an example, the driver of the automated car. Taxi. So if the car in front brakes and its brake light come on, then you should notice this and initiate braking. So in other words, we can say that some processing is done on the visual input to establish the condition. We call the car in front is braking. So then this triggers some established connection in the agent program to the action initiate braking. So we call such a connection a condition action rule. So if a particular condition occurs, then a particular action should be taken. So that is condition action rule. So here the front car is applying brake. So the sensor perceives the environment and it collects that information that the front car brake light is on. So here we have to initiate the action, that is we have to apply the brake. So if car in front is braking, then initiate braking. That we can call it as condition action rule. So this is the architecture of the simple reflex agent. Here we can see the sensors that collect information from the environment. So what the world is like now. So that is the percent. And then it will check the agent program that will check the condition action rule. So condition is that will be depending upon the percent and the corresponding action will be selected. So what action I should do now? So the particular action will be selected according to the percent and the actuator will do or execute the corresponding action. So we will see the agent program. A simple reflex agent takes action based only on the current person using the condition action rules. So here we can see the function is called every time a new person arrives. So rules are stored permanently. So and this you can see that persistent here rules and a set of condition action rules. So then what the sensor is collecting information from the environment that we can consider it as a raw percept. So that should be converted into a particular format. So that is actually simplifies the sensor input. Then agent searches through the rules and find the first rule whose condition matches the current state, then extract the action part from the match rule. So there is no calculation or no planning. So then action is executed immediately. Second type of agent program is model-based reflex agents. The most effective way to handle partial observability is for the agent to keep track of the part of the world it can't see now. So the agent should maintain some sort of internal state that depends on the perceived history and thereby reflects at least some of the unobserved aspects of the current state. So that means here it will consider the current percepts. Along with that, it will consider the perceived history also. So accordingly, they will check the condition action rule and they will select the action. So, in the example here, we can see that. So, can a self-driving car rely only on what its sensors see at this particular moment? No, because the real world is partially observable and dynamic. So, this naturally introduces model-based reflex agents. So, we can say that a model-based reflex agent uses the current percept plus an internal model of the world to decide actions. So, internal model means we can consider the internal model in automatic taxi means automatic taxi maintains an internal state that represents aspects of the world not immediately visible. That includes road maps and lane structure, current position and speed, traffic signal states, positions and speed of nearby vehicles, pedestrian movement predictions, and traffic rules and constraints. So these are we can consider as the internal model. So not just what it sees now, that is we can consider it as internal, but also what it remembers and predicts. So why an automatic taxi is not a simple reflex agent? We can say that roads are dynamic. So sensors may be imperfect. Some information is not immediately visible. So a car ahead suddenly brakes. Pedestrian hidden behind another vehicle. So traffic signal just turned yellow. So we should then in these cases, so there we need the internal model. So automatic taxi operates in a partially observable and dynamic environment. So partially observable means cannot see everything at once. Dynamic means environment changes while agent is thinking. So here we can see that we already discussed everything. We will see taxi updates its internal states using previous state, current percepts from sensors, knowledge of how the world changes, knowledge of how action affect the world. For example, if a vehicle was observed in the blind spot a moment ago, a taxi assumes it may still be there. If brakes were applied, the taxi expects speed to decrease. So these we can consider as the internal state. Then for a reflex rule-based model, taxi uses condition action rules. So, but these rules are applied to the internal state, not just the raw percepts. In the previous case, we are only considering the current percept, but here we are considering the internal state also. For example, we can see if traffic light ahead is red, then apply brake. If vehicle detect a head slowing down, then reduce speed. If lane deviation detected, adjust steering. If obstacle predicted in path, change lane or stop. So these things we can include in the internal state. So these rules allow quick real-time reaction essential for safety. So road environment are partially observable. We already discussed this. Sensors have limited range or objects can be hidden. Weather affects perception. So we are considering the internal state also. The internal model helps the taxi fill in missing information, making safer decisions. So this is the architecture of model-based reflex agents. Here we can see the sensors that will collect information from the environment, and here we can see there is a how the world evolves state and how the world evolves and what my action do. So that means that are the internal state. So we will consider the internal state along with the current percepts. Then the agent will check the condition action rule, and if a match is found, then the actuator will do or execute that particular action. Next, we can see the agent program for the model based agents. So the agent program that receives a percept, that means the input from the environment, and updates its internal state, then it will check the matching rules based on the updated state and chooses and return an action. So here we will see the line by line explanation of the code. The first is actually a function. This function takes the current percept and return an action. Then the persistent variables are state, model, rules, and action. State means agent's memory of the world. That means what it believes about the environment. And model means the knowledge of how the world changes, how actions affect the state. Then rules means condition action rules. And then action, that is the last action taken, and initially it is none. These are the persistent, meaning they are remembered across time steps. Next is update the state. So that means it uses the previous state, previous action, and current percept and model of the world and produce a new internal state. And this is the main difference from the simple reflex agents. Next is rule matching. So that means it finds the rule whose condition matches the current state. Next is selecting the action, that is execute the action specified by the matching rule. Then it returns an action. That means the chosen action is sent to the environment. So we can say that a model-based reflex agent maintains an internal state using a world model and selects action by applying condition action rule to the updated state. Next agent program is goal-based agents. So the agent needs some sort of goal information that describes situation that is desirable. For example, being at the passenger's destination. So we will see the example. How do you decide your route when you are going to college? You first think about where you want to reach. You choose actions that move you closer to that goal. That is exactly how a goal-based agent works. So agent asks, if I do this now, where will I end up? It compares different possible action sequences. For example, we will discuss taxi. If it turns left, there is a traffic jam is there. Go straight, then clear road. Then we will choose or agent choose straight road. The God-based agent chooses actions by considering future consequences and selecting those that lead to closer to achieving its goal state. So search and planning are the subfields of AI devoted to finding action sequences that achieve the agent goals. So that means in goal-based agent, we will consider all possible solutions and we will choose one better action that led to closer to achieving the goal state. We can see the architecture of goal-based agent. Here, the input phase, that is sensors and percepts. The process start at the sensors. Sensors provide percepts, that means raw data, but raw data is incomplete. So the internal state, that is the core of this agent, and what is the world like now and how it works. So we will see how it works. The agent combines the new percept with its previous memory. So that means the internal state. This consists of two pieces of knowledge. One is evolution. That means how the world moves on its own. For example, we can say that if a ball is thrown, it will fall. So we already knows this. That is the built-in knowledge. Then action effects. What the agent's own action do. So that means if I turn the wheel, the car moves left. So if I do the action A, so what will be the result? Then the planning phase. This is what makes the agent goal-based. It doesn't have a set of if-then rules. It has a destination. The agent picks the action that brings it closer to the goal state. Then we have the output phase, that is actuators and actions. Once the best action is selected, it is sent to the actuators and the action changes the environment, which creates a new percept and the cycle repeats. Here, this is the detailed explanation. Agent perceives the environment, defines or recognizes a goal, evaluates all possible outcomes and their actions and their outcomes, then chooses the action that moves it closer to the goal and execute the corresponding action. Example, for a chess playing agent, the goal will be checkmate opponent. So what he will do, he will evaluate future board positions and chooses moves that increase chances of winning. That is the best example of goal-based agent. Next is utility-based agents. Reaching a goal is not always enough. How well we reach it also matters. So we can consider two routes reach the destination, route A and route B. Here the route A is long and safe and route B is short and risky. So both achieve the goal, but one is better. This leads to utility-based agents. We can see what is utility. Utility means actually a numerical measure of how desirable a particular state is to the agent. So higher utility means agent is happier, lower utility means agent is less satisfied. We can set the utility of each action. So if the safe plus and first route, that means our route A. So there we can set the utility as 90. Risky but fast, that means route B, we can set the utility as 60. So there will be a utility function. So utility function is essentially an internalization of the performance measure. So a more general performance measure should allow a comparison of different goal states according to exactly how happy they would make the agent. So an agent utility function is essentially an internalization of the performance measure. So performance measure, that is actually external. Utility function is internal, that is used by the agent, and the performance measure is actually given by the designer. So the agent converts the external code into numeric score. So that means they will calculate some um, function, and they will calculate the function and they will get a value. So agent perceives the environment and predict all possible future states, then calculate the utility of each state and select the action that maximizes the expected utility and execute the corresponding action. And here, the maximizing utility means maximizing performance measure. So here we have already seen the example. There we have multiple routes. So evaluate the multiple routes, then chooses the one with the highest utility, not just the shortest path. A utility-based agent selects the action that maximizes expected utility, considering all possible outcomes and how desirable they are. It is not just reaching the goal, but choosing the best possible outcome. A goal-based agent only decides whether a goal is achieved or not. But in many cases, there are multiple acceptable outcomes will be there, and some outcomes are better than the other. Then the utility-based agent allow comparison between outcomes. So that means each action may lead to multiple possible outcomes, and each outcome has a utility value. That means how good it is, and there is a probability will be there. That means chance of occurrence. So agent chooses the action with the highest expected utility. So here the limitations of the goal based agent that can be overcome using this utility based agent. That means in the goal based agent we are checking whether the goal achieving or not. But in a real time environment, many outcomes can reach the goal. Some outcomes are better than the other. So that means if you are considering an example, reaching a destination. The first case, in 20 minutes we will reach. That is the better solution. In another case, in 40 minutes we will reach. That is acceptable. And the third case, in 1 hour we will reach. So that is poor. So goal-based agent treats all these cases equally, but in the utility-based agent compares the quality. Then, if you are considering another example, self-driving car, there will be different routes. All routes may leads to the destination, but we can consider different factors like safety, time, comfort, fuel efficiency, and all. And the utility-based case agent, it evaluates all the routes and computes the expected utility and chooses the best overall option. Next, we will see the architecture of utility-based agent. Here also the sensors collects percept from the environment, and these percepts describe the current situation. Next, we have internal state that represents agent's current understanding of the world, that may include information not directly observable. Then model of the world, that includes how the world evolves. That means describe how the environment changes on its own. We already discussed in the previous case. For example, traffic lights change, other vehicle move. Then what my action do? That describes how agents' actions affect the world. For example, accelerating increase speed, turning that means car turns, that changes the direction. Next is actually prediction. What it will be like if I do action A. So agent simulates future states. For each possible action that predicts what will be the resulting state. For example, if I take route A, I will reach in 30 minutes. If I take route B, I will reach in 40 minutes. So here I will consider the utility function. How happy I will be in such a state. Assigns a numerical value to each possible state and measure how desirable a state is. For example, in the case of a taxi, we are considering the utility factors, safety, time, comfort, and fuel efficiency. So higher utility means better outcome. So next is decision making. So there, what action I should do now. So agent calculates expected utility for each action and chooses the action with the maximum expected utility. This is the core of the this utility-based agent. And then we have actuators execute the selected action in the environment. The environment changes and the cycle repeats. Next, we will see this is the explanation of the utility-based agents we already discussed. That is, the agent perceives the environment, generates all possible outcome actions, and predicts outcomes of each action, calculates the utility value for each outcome, and select action with the maximum utility. For example, medical diagnosis system, utilities assigned to treatment, success, risk, and cost. So these are the performance measure we have considered: treatment success, risk, and cost. And utility value also assigned to all these cases. Then chooses the treatment with the maximum patient benefit. Next is learning agent. A learning agent is an intelligent agent that improves its performance over time by learning from experience and feedback from the environment. Human beings are the classic examples of learning agents. Here we can see the architecture of the learning agent. There are four main blocks: performance element, critic, learning agent, and problem generator. We will discuss one by one. First, we will see performance element. It selects action based on the current percepts, and it is directly interacting with the environment. It takes the input from the sensors. Here in the figure we can see that the sensor collect information from the environment, and this is the input to the performance element. And it chooses actions through the actuators. For example, in a self-driving car, steering, braking, accelerating. So this part is responsible for current behavior. The next block is critic, that evaluates how well the agent is performing. There are two inputs to the critic. First one is percept from sensors, and the second one is performance standard. And the output will be feedback to the learning element. So, for example, it tells the agent, your last decision reduces fuel efficiency. The critic does not decide action, it only judges performance. Next is learning element that improves the agent's behavior over time, uses feedback from the critic, and modifies the knowledge of the performance element. For example, update the rules or models, learn better strategies. So this component is responsible for learning and improvement. And the next one is problem generator that suggests new actions or exploratory behaviors. If the agent only exploits known actions, learning stops. Exploration helps discover better strategies. For example, trying a new route instead of the usual one. Then interaction with the environment, sensor receive pulses from the environment, and actuators that execute action chosen by the performance element. So we already discussed these four components of the learning. The working of a learning agent we already discussed. Anyway, we will just go through it. Agent perceives the environment. Performance element select an action. Action is executed. Critic evaluates the result. And learning element updates knowledge. And problem generator explores new actions. We will see the example learning agent in automatic taxi. We will see in detail in the next slide. In this slide, we will discuss about the four components of learning agent using an example automated taxi. So we will see each components. First one is performance element. That means what the taxi does. The performance element contains, in this case, driving rules, traffic laws, navigation algorithms, control procedures like steering, applying brake, accelerating, etc. So, selecting a driving action such as turning left or right, accelerating, braking, changing lanes are done by this performance element. The taxi drives on the road using its current knowledge. So, this part acts directly in the environment. And the second component is critic, who judges the taxi. So, the critic observes the taxi's behavior and environment's response. What it will check? It will check safety, passengers' comfort, traffic rule violations, reactions from other drivers, etc. So We are considering an example. After the taxi makes a dangerous quick left turn across three lanes, then the critic will conclude this action was bad. So next we will consider the next component, learning element. Who improves the taxi? The learning element uses feedback from the critic and learns that the action was unsafe. So in the previous example, from the feedback from the critic, the learning element formulates a new rule. Avoid sharp multi-lane turns in heavy traffic. So it updates the performance element by installing the new rule. So the taxi does not repeat the mistake in future. And the fourth component, problem generator, who encourages experimentation. The problem generator suggests new experiments to improve behavior. So testing braking behavior on wet roads, muddy roads, high-speed highways. These are the examples. So that helps the taxi learn faster and safer. Next is hybrid agent. Hybrid agent is an intelligent agent that combines two or more agent architectures, such as reflex, model-based, goal-based, utility-based, and learning agent to achieve better performance, flexibility, and adaptability. An automated taxi is a classic example of a hybrid agent. It uses reflex behavior to brake immediately when an obstacle appears, a model-based approach to track nearby vehicles and traffic conditions, and a goal-based strategy to reach the passenger's destination, and a utility-based method to choose the safest and fastest route, and learning capabilities to improve by understanding traffic patterns and user preferences over time. And the next one is problem solving agent, that is similar to goal based agent. And we will discuss this problem solving agent in detail in the next week. Thank you.